These are the notes for section 1 on sequences, series, and sigma notation. You're going to take notes at your own pace, and you can stop and rewind at any point. So there's quite a bit of vocabulary in this section, so we're going to go through that. A sequence is an ordered list of numbers. Each number in the sequence is a term. A finite sequence contains a finite number of terms, so that means it's a countable amount. An infinite sequence contains an infinite number of terms. An explicit formula gives the nth term as a sub n as a function of n. So explicit formula is what we're used to using in math so that you could plug in an n value and find out what it equals to in the equation. The recursive formula is used to determine the nth term of a sequence using one or more of the preceding terms. So in a recursive formula, you have to know the term before to find the next term in the sequence. As a function, an infinite sequence may have a limit. If a sequence has a limit such that the terms approach a unique number, it is said to converge. If not, the sequence is said to diverge. So before we talked about limits earlier in the year, and when it gets closer and closer to an actual number, then it converges. If that is getting closer and closer to infinity, then it diverges. So a series is the indicated sum of all the terms of a sequence. A finite series is the indicated sum of all the terms of a finite sequence. An infinite series is the indicated sum of all the terms of an infinite sequence. The sum of the first n terms of a series is called the nth partial sum and is denoted as sub n. So a series is written using summation notation or sigma notation with the Greek letter sigma. For any sequence A1, A2, A3, A4, the sum of the first k terms is denoted. And I would read this, the sum of the sequence from 1 to k. So 1 is the starting position or the lower bound, and k on the top is the upper bound of the summation. So example 1 says find the next 4 terms of the sequence. So I have 3, -1, -5, and -9. So my goal is to figure out what's happening from term to term. So from -3 to -1, it looks like that we are subtracting 4 from the sequence. So I want to see, does that pattern continue or is something else happening? So to go from -1 to -5, I would also subtract 4. And -5 to -9, I would subtract 4. So if you see a pattern, then you're just going to continue that to find the next 4 terms. So from -9, and if I subtract -4, that's going to be -13. -13 minus 4 is going to give me -17. -17 minus 4 will be -21. And -21 minus 4 is -25. So those are the next 4 terms in the sequence. So example 2 says find the next 4 terms of the sequence again. So I'm going to try to figure out what the pattern is. So to go from 18 to 15, I would subtract 3. So I want to see, does that pattern continue or is there something else going on? To go from 15 to 10, I would subtract 5. So I see that these aren't the same number from term to term, so I want to see what other underlying pattern is happening. And to go from 10 to 3, we would need to subtract 7. So I can see so far with these numbers, it's not the same value every time, but each of these is an odd number. So if I continue the pattern with the odd number, we'll continue the sequence. So the next number we would want to subtract is -9, or add -9. So from 3 minus 9 will give us -6. The next odd number would be -11. So -6 minus 11 is -17. Next would be -13. So -17 minus 13, -30. -15 is the next odd number, so -30 minus 15 would be -45. So sometimes it may not be the same number each time. It might be odds or evens, or there's another pattern going on in that subset. So in example 3, it says to find the next 4 terms of the sequence. So we're going to plug in 1, 2, 3, 4 into the sequence and find the sequence of numbers. So a sub 1 means I plug in a 1 for n. So 1 cubed plus 1 is going to equal 1. We're going to substitute 2 for the second term in the sequence. So 2 to the third power plus 1 will equal 9. A sub 3 will be 3 to the third power plus 1 is 28. And then a to the fourth, or a sub 4 would be 4 to the third power plus 1 equals 65. So those are the first 4 terms of this sequence. Example 4 says find the next 4 terms of the sequence. So same thing, we're going to plug in 1, 2, 3, 4 for n and find out what the value is. So a sub 1 will be 2 times 1 times negative 1 to the first power. That's going to equal negative 2. A sub 2 is going to be 2 times 2 times negative 1 to the second power, which would be 4. A sub 3 is going to be 2 times 3 times negative 1 to the third power, which will equal negative 6. A sub 4 is going to be 2 times 4 times negative 1 to the fourth power, which is 8. So on this one you can see that the pattern is even numbers, but then they also alternate positive and negative. Example 5 says find the 10th term of the sequence. So for this, all we have to do is plug in 10 for n and find this one value. So 10 to the second power minus 3 is going to be 100 minus 3, which is 97. Example 6, again, finding the 10th term of the sequence. We're just plugging in 10. So a sub 10 is going to equal negative 5 times 10 plus 3 divided by 10. So negative 50 plus 3 divided by 10, which is negative 47 divided by 10, and you can write that as negative 4.7. Next, on example 7, we're finding the sum of the sequence. So this means to find the sum of the sequence from 1 to 4 of n squared minus n. So we're going to plug in 1, 2, 3, 4 and find the value of that sequence, then add them together for the sum. Okay, so first we're going to plug in 1 for n. So this would be 1 squared minus 1, which will equal 0. Then we're going to plug in 2. So 2 squared minus 2, which is going to equal 2. A sub 3 will be 3 squared minus 3, which equals 6. A sub 4 will be 4 squared minus 4, which equals 12. So once you find the value of the sequence, then you just plug those in to add those together. So 0 plus 2 plus 6 plus 12 is equal to 20. So that's the sum of the sequence from 1 to 4 of n squared minus n. Last example, this one is the sum of 30 minus 4n from 4 to 11. So we're going to start at 4 and stop at 11. So I've written out all of my blanks that I'm going to find the sum of from 4 to 11, find each of those values, and then plug them in. So a sub 4 is going to be 30 minus 4 times 4, and that will equal 14. A sub 5, 30 minus 4 times 5 is 10. A sub 6, 30 minus 4 times 6 is 6. And then I start to notice a pattern. Okay, we're just subtracting 4 from here on out. So if I continue to subtract 4, I can fill in the rest of those numbers instead of actually calculating them. So the next would be negative 2, negative 6, negative 10, and negative 14. This time when I add these together, I notice that I have positives and negatives that are the same value. So anytime that happens, those are going to cancel out. So the 14s would cancel, tens would cancel, sixes and twos. So if everything cancels, then the sum of this sequence is actually 0.